There's another way that roots can be expressed, and that is using rational exponents. So as you see, we have the nth root of x to the r. We can write that as x to the r. So notice that r is still the exponent of x. How we represent that it is part of a root or a radical is we take this index and we divide that exponent. So we can write any radical as a fractional exponent. So let's practice rewriting some of these formats. In I, we have an index of 3, an exponent of 5. So we would write x to the 5th divided by 3. In J, notice we do not see an index or an exponent. If it helps you, you can write them in. Remember, a square root is an understood index of 2. Think of squaring. Exponent is an understood exponent of 1. So we would get x minus 7, exponent of 1 divided by the index of 2. So the binomial x minus 7 to the power of 1/2. Now let's go backwards. In K, we have y to the 5/6. So again, the denominator, that's kind of the new part. We're not used to seeing fractions, right? But if you have a denominator of a fraction other than 1, that's going to be our index. So we get 6th root of y to the 5th. Same thing. We have a denominator of 3, so that means we have a cubed root of the whole binomial 4x plus 1 squared. Now, if we are solving equations that have those fractional exponents, there's a couple of different ways we could do them. I'm going to show you both methods using these two examples here. If you want to just get rid of that fraction, let's say x plus 4th to the 5/3, I'm going to write it a little bit bigger so you can see. We would love to have an exponent of 1. So what we would do is take this entire side to the reciprocal, 3/5. Because remember, with our exponent rules, we would multiply those exponents. But if we do it to the left, we must also do it to the right. So 32 to the 3/5. When we multiply these two, we get 15 over 15, which is just x plus 4 to the first power. And then we get 32 to the 3/5. It's up to us if we want to leave it in terms of fractions. My rule of thumb is usually if it started with a fraction exponent, leave it as a fraction exponent. But sometimes these can be reduced. We can simplify any of those numbers using our calculator or Desmos.com online. We can type in 32, and you can either use the hat that's on your keyboard, or you can use a to the b or x to the b to get up here in the exponent position. And then just put in 3 divided by 5. Just make sure that entire fraction is in your exponent, and it will actually give you the result here. We love Desmos. And of course, it's always good to know how to do it by hand as well. So I'm going to write it as the 5th root of 32. And we could take that cube of the 32, or we could take the cube to the outside. That's completely up to us. We get x equals the 5th root of 32 cubed minus 4. And I want to see if that 32 cubed can reduce. Let's look at 32 first. If we break it down, we've got 2 times 16, 2 times 8, 2 times 4. Hey, look at there, 2 times 2. I have 1, 2, 3, 4, 5 2s. The reason I'm waiting to see kind of where I want to put that 3, whether it's on the outside or the inside, and I can do that here too. The nth root of x to the r is the same thing as the nth root of x to the power of r. is that I can look at just this fifth root of 32, and that reduces to the number 2. I can cube that 2 minus 4. 2 cubed is 8. 8 minus 4 gives us a 4. We can go ahead and check that, but just to save time, we'll leave it as it is. Now, for n, if you wish, we can go ahead and isolate the fraction exponent there and its base. That would give us 2x minus 1 to the 2/3. After dividing both sides by 5, we get what? 25? If it is easier for you to see it, we can always rewrite it as the cubed root of 2x minus 1 quantity squared equals 25. And then just get rid of both pieces one at a time. In other words, let's cube both sides to get rid of that radical. 25 cubed, 15,625. But now we're going to want to get rid of that square. So now we take the square root of both sides, leaving us with 2x minus 1 equals 125. Then we can continue to get x by itself, add 1 to both sides, and divide both sides by 2. And again, we can always plug that number back in to check.